Hi guys, this is O-Level Chemistry, Paper 1, Specimen 2023, Question 31. Which compound has the lowest percentage by mass of nitrogen? So the MR of the compounds are given. We need to find out the percentage of nitrogen present in each compound. In order to do that, what we must do is calculate the number of nitrogen atoms present and then multiply it by the mass of nitrogen, which is 14. So for option A, we have got two nitrogen atoms present. So 14 twos are 28. The 28 divided by 60 into 100 gives us a value of 46.67%. Similarly, now we move on to option B. Option B has again two nitrogen atoms present, so it would become 28 divided by 132 is the MR here into 100. This would give us a value of 21.21%. Moving on to option C, we have 3 moles of nitrogen atoms present. So 14 threes are 42. 42 would be the numerator divided by 149, which is the MR of the salt, into 100. And this would give us a percentage value of 28.19. Moving on to our last option, option D, we have 2 moles of nitrogen present. So 14 twos are 28. 28 divided by MR is 80 into 100. This gives us a value of 35.00%. So the question has asked us which compound has the lowest percentage by mass of nitrogen. So out of these four calculated values, the lowest value is 21.21, which belongs to option B, making option B the correct answer for this question. Question 32. The diagram shows the structures of 5 hydrocarbons. Which 3 hydrocarbons are isomers of each other? So the definition of isomer states that isomers are molecules having the same molecular formula but different structural arrangements. So in order to find out which of these are isomers, we need to find their molecular formulae. So let's do that. In the first example, we have got 5 carbon atoms and we have got 5 plus 5, 10 and 2, 12, 12 hydrogen atoms. So the molecular formula of the first compound is C5H12. Moving on to the second structure, again we have got 5 carbon atoms and we have got 3 plus 3 plus 3 plus 3, 12 hydrogen atoms. So structures 1 and 2 are isomers of each other. Moving on to structure 3 has 4 carbon atoms, which means it is not an isomer of structures 1 and 2. And it has got 10 hydrogen atoms. So this is not an isomer of C5H12. Moving on to structure 4. Structure 4 again has 5 carbon atoms present and 12 hydrogen atoms present. So structure 4 is an isomer of structures 1 and 2. Moving on to the last structure, structure 5, we see 4 carbon atoms present along with 10 hydrogen atoms. So structures 3 and 5 are isomers of each other, whereas structures 1, 2, and 4 are isomers of each other. And our question asks, which 3 hydrocarbons are isomers of each other? So the 3 hydrocarbons that are isomers of each other are structures 1, 2, and 4, which makes option A the correct option for this question. Question 33. The diagram shows a fractionating column used in the separation of petroleum. Which rows explain why fraction R is collected above fraction S? And the properties that they are using here are boiling point and average molecular mass. So we need to remember that the fractionating column separates the fraction based on their MR and boiling points. How? the fractions with the lowest boiling point and the lowest MR are collected at the top of the fractionating column, and those with the highest boiling point and the highest MR are collected at the bottom. So, as the boiling point increases, the fractions are collected down in the fractionating column, and as the MR increases, they are collected down in the fractionating column. So our question is asking us which row explains why fraction R is collected above fraction S. This means that fraction R must have a boiling point that is lesser than fraction S, right? And it must have a molecular mass which is also lesser than fraction S. So both the boiling point and the average molecular mass of R must be lesser than S. Here the terms used are greater and smaller. So they both must be smaller than S. So option A, greater than S, wrong. Option B, greater than S, wrong. Option C, smaller than S, yes. Option D, smaller than S, yes. So eliminating options A and B, we have options C and D present. Now, this will be decided on the base of the average molecular mass. So, we need to recall R has a smaller molecular mass than S. Option C states that it has a greater mass than S. So, option C is incorrect. And option D says smaller than S, making it correct. Therefore, option D is the correct option for this question. Question 34. Which compound is an alkane? And all of the options contain C31. So we need to recall that the general formula of an alkane is CnH2n plus 2. Since all of these options have 31 carbon atoms present, so this would become C31. H would be 2 into 31 plus 2. Now 2 into 31 makes it 62. 62 plus 2 makes it 64. So the correct option would have C13, oh sorry, C31 and H64 in it. Therefore, option D is the correct option for this question. Question 35. Which row correctly describes alkenes? Now, alkenes are unsaturated hydrocarbons. Unsaturated means they have a double bond present in them. So options A and B have been eliminated automatically. Options C and D both contain unsaturated. So the correct option will be one of these two. And the other column says results when shaken with aqueous bromine. Now, a test for alkenes is that when aqueous bromine is shaken with alkenes or the double bond present in them, the double bond reacts with bromine present, and the color of bromine discharges or decolorizes. So, in other words, if you add alkenes to aqueous bromine, the brown color disappears. So option C says no change, which is wrong. And option D says the aqueous bromine is decolorized, which is correct, making option D the correct option for this question. Question 36. A carboxylic acid with the molecular formula C4H8O2 reacts with an alcohol with the molecular formula C3H8O to form an ester. Now, if we look at all of these four esters, all of them are straight chains. So what we can do is we can write the reaction and find out the product and see which product is the correct product out of these four options. So the carboxylic acid has four carbon atoms. So that would be CH3, CH2, CH2, COOH reacting with an alcohol with three carbon atoms. So CH3, CH2, CH2, and OH. And when these react, the alcohol loses its OH and the carboxylic acid loses its hydrogen. And the alcohol adds onto the remaining portion of the carboxylic acid. So the product here would be CH3, CH2, CH2, C double bond O, single bond O, and then the alcohol part would start. That would be CH2, next to another CH2, next to another CH3. So in the ester, the alcohol portion would contain 1, 2, 3 carbon atoms, and the carboxylic acid portion would contain 1, 2, 3, and 4 carbon atoms. So if you look at option A, it has 1, 2, 3, 4 carbon atoms in the alcohol portion, making it incorrect. In option B, we have 1, 2, and 3 carbons for the alcohol portion, and 1, 2, 3, and 4 carbon atoms for the carboxylic acid portion, making B the correct option. Option C again has 1, 2, 3, 4 carbon atoms for the alcohol part, making it incorrect. Option D has 1, 2, and 3 carbon atoms for the alcohol part. This part is correct. Let's look at the part for the carboxylic acid. 1, 2, and 3. 3 carbon atoms instead of 4, so this is wrong. This makes option B the correct option for this question. Another thing, the ester formed has a name. How do we name it? First, we write the name of the alcohol part as 3 carbon containing alcohol. It will become propyl, and a 4 carbon atom containing carboxylic acid, making it butanoate. So the correct answer is propyl butanoate. Question 37. The repeat unit of a polymer is shown. Now we can conclude by looking at this repeat unit that this is an addition polymer and not a condensation polymer. Why? Because a condensation polymer would contain an ester bond or an amide bond. None of these bonds are present in this molecule. So this is an addition polymer. So addition polymers are formed when the double bond opens up. So the double bond must be present between these two carbon atoms. So this shows that the carbon on the left has a CH3 and a hydrogen attached to it, and the carbon on the right has a chlorine and a bromine attached to it. If we look at structure A, the carbon on the left has a hydrogen and CH3 present, which is correct, and the one on the right has a chlorine and bromine present, which is also correct. Option A is the correct option for this question. Let's look at the incorrect options. Option B is incorrect because instead of the chlorine and bromine atoms being present on the same carbon atom, they are present on two different carbon atoms. Same situation in option C, chlorine and bromine are present on two different carbon atoms, and the same situation in option D, chlorine and bromine are present on two different carbon atoms, whereas in the repeat unit, they are present on the same carbon atom. Thus, option A is the correct option for this question. Question 38. When heated, magnesium reacts with oxygen in air to form magnesium oxide, a white powder. A student investigates the change in mass that occurs during this reaction. The student is given a balance and three sets of apparatus shown. So basically, the experimental procedure that must be employed must have a way of measuring the mass of the solid. Okay. So in experiment 1, metal tongs are used and magnesium is burnt in flame. So if the magnesium oxide is produced in this case, it will just drop off and it cannot be measured. So the setup of apparatus 1 is incorrect for the required investigation. Let's look at the setup for experiment 2. In this case, air is passed over heated magnesium inside a glass tube, which can be cooled and mass measured. So, mass of magnesium before the reaction and mass of magnesium oxide after the reaction can be measured when the apparatus is cooled to room temperature. So, measurement of mass is possible in the second setup. In the third setup, we have a crucible with magnesium in it, and it is being heated on a tripod. So in this case also, before the heating is done, the mass of the crucible plus magnesium metal can be measured, and after the heating is done, the apparatus can be cooled and the mass of the crucible and magnesium oxide it contains can be measured. So measuring of mass is possible in the experimental setup 3, which needs to be investigated, making experiments 2 and 3 correct modes of investigation and experiment 1 incorrect. So, as a result, the correct answer for this question is option C. Question 39. A student uses paper chromatography to find an RF value for Fe3 plus aqueous ion. The result is shown. Which row correctly completes gaps 1 and 2? Now, the statement here is to make the spot containing Fe3 plus more visible, the paper is sprayed with an aqueous sodium hydroxide so that precipitate of iron 3 hydroxide forms. Under the conditions of the experiment, the RF value for Fe3 plus is given by, this is gap 1, and the color of the precipitate is given by, this is gap 2. So, RF value is the distance traveled by the solute upon the distance traveled by the solvent. Here, solute travels a distance x and solvent travels a distance y. So options A and B have x upon y in them, making option C and D incorrect. And now we have Fe3 plus ions. So the color of Fe3 plus ions is red brown, whereas color of Fe2 plus aqueous ions is green. So we have Fe3 plus present here. So the color that would be observed would be red brown. This makes option B as the correct option for this question. Question 40. Tests on an aqueous solution of an unknown compound P are shown in the table. Aqueous sodium hydroxide is added, a green precipitate forms, soluble in excess giving a green solution. This is a test for the presence of Cr3 positive ions. So, Cr3 positive ions are present in our unknown compound. Next test, dilute nitric acid added, then barium nitrate, and a white precipitate forms. This is a test for the presence of sulfate ions because a white precipitate of barium sulfate will form. Next, dilute nitric acid added and then aqueous silver nitrate. Silver nitrate is used as a test for the presence of chloride, bromide, or iodide ions. Here, no precipitate forms, so this signifies that absence of chloride, bromide, and iodide ions in the unknown compound P. So, what we have concluded is that in our unknown compound, chromium ions and sulfate ions are present. Option A contains chromium and chloride. Chloride is absent. Option B contains chromium and sulfate. Option B is the correct option. Option C contains iron and chloride. Neither iron 2 plus nor chloride ions are present. And option D contains iron 2 plus, which is not present, and sulfate, which is present. So, both ions that are present, chromium 3 plus and sulfate ions, are present in option B, making option B the correct option for this question.